Hi guys, welcome back to Worms Maths Academy. Now we're going to have some fun with first principles, which everyone seems to love. What is first principles? Well, it's creating, finding derivatives by using differentiation. Well, it's how differentiation comes about. What it is, basically, if we have a graph, I've got a point here, let's say that's x, and then I've got another point here, x plus h. We know that this value here is f of x. This value here is f of x plus h. If I wanted to find the gradient between those 2 points, we know that our gradient is f of x plus h minus f of x over x plus h minus x. They will cancel, x minus x. So we've got f of x plus h minus f of x. That gives us our gradient between 2 points. But if I want my gradient at a single point, like at the point x, what I do is I make h get really small. So the distance between x and x plus h, I make that small. What's the smallest thing you could do? Well, you could say the limit as h approaches 0 of f of x plus h minus f of x on h, which is that. That will tell you, as h approaches 0, what this function will actually become, what this thing here, what the gradient will actually be at that point x. So that's where the instantaneous gradient is derived from. The limit as h approaches 0, f of x plus h minus f of x, so this point here minus this point here, the gradient between the two, but we make h, the value between the two, approach 0. Okay, so how do we do it? Well, we need f of x plus h, f of x. So we've got f of x. F of x plus h means wherever you've got an x, you've got to replace it with an x plus h. So 4x plus h squared plus 3x plus h minus 6. Of course, we know that's 4x squared plus 2hx plus h squared plus 3x plus 3h minus 6, which is 4x squared plus 8hx plus 4h squared plus 3x plus 3h minus 6. So we can say f dash x is therefore our limit as h approaches 0. Now don't forget, this has to be in this order. So the f dash of x is equal to the limit as h approaches 0 of f of x plus h. So 4x squared plus 8hx plus 4h squared plus 3x plus 3h minus 6. And then it's subtract all of f of x. So put it in a bracket, 4x squared plus 3x minus 6 over h. Now, this, if it's a polynomial, will always cancel. So 4x squared, 3x, negative 6 minus is plus, so they cancel. So we say, once again, you've got to make sure you keep putting the limit as h approaches 0 of, now I've got 8hx, 4h squared, and 3h, so I'm going to take out a h as a common factor. So I get 8x plus 8h plus 3 on h. They cancel. Now we can sub in h equals 0. 8x plus 8 times 0 plus 3, which is 8x plus 3. So that means my gradient on this line at any value x is given by f dash of x is 8x plus 3. Here we're going to do it again, but this time we've got x cubed. Now, I'm going to have f of x plus h, which is 2 x plus h cubed minus 6x x plus h. Now, a lot of people don't know how to expand out a perfect cube quickly. There's something called Pascal's triangle. And what that does, it starts with a 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. All I'm doing is I'm adding the two values above to the left and to the right. So here, 3 is 1 and 2, 3 is 1 and 2. Here, 4 is 1 and 3. 6 is 3 and 3. That's 4. That's 1, 1. So, and this gives me my coefficients when I expand. So if I had a plus b squared, we get a squared plus ab, 2ab plus b squared. That's what you'd get if you expanded it out by hand. If you have a plus b cubed, well, that's a cubed plus 3a squared b plus 3ab squared plus b cubed. If you have a plus b to the power of 4, well, that's a to the 4 plus 4, a to the 3, b to the 1, plus 6, a to the 2, b to the 2, plus 4, a, b cubed, and then plus b to the power of 4. And what you'll see is my highest power, my first thing starts with the highest power, 4. Then it goes down, 3, 2, 1, 0. My second thing starts at a 0. Then it goes to 1, 2, 3, 4. Together, the powers always add up to 4. And my coefficient is determined by Pascal's triangle. So, let's go through another one. If I had x plus 4 to the power of 5. So this is when it's squared, this is when it's cubed, this is when it's to the 4. So if we want to the 5, 1, 5, 10, 10, 5, 1. So I'll move this over here. We'll say x plus 2 to the power of 5. So 1, 5, 10, 10, 5, 1. First one, x to the 5, x to the 4, x to the 3, x to the 2, x to the 1, x to the none. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and 2 to the 5. And then pluses in between them all. Okay, so we get x to the 5, and then plus 10x to the 4, plus 40x to the 3, plus 80x to the 2. 2 to the power of 4 is 16 times 5 is 80x. Then 2 to the power of 5 is 32. Now, someone said to me, what about if I have a negative? What about if I had, say, x minus 2 to the power of 4? So it works on the same principle. Go to the fourth level. 1, 4, make a bit more, 4, 6, 4, 1, x4, x3, x2, x1. Then I have negative 2 to the 0, negative 2 to the 1, negative 2 to the 2, negative 2 to the 3, negative 2 to the 4, plus, 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 plus. So I get x to the 4 minus, because 2, 8x to the 3, 2 squared, negative 2 squared is positive 4, so I get plus 24x squared. Negative 2 cubed is minus 8 times 4 is negative 32x. Negative 2 to the 4 is plus 16. So that's it expanded. Now you don't necessarily have to know that anymore because your calculator expands all this stuff, but you could also get how to expand a cubic, and it's really worthwhile to know how to do it quickly. So in this case here, I know I'm going to get 2x cubed plus 3x squared h plus 3xh squared plus h cubed minus 6x minus 6h. So I get 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 6x minus 6h. We know f dash of x is the limit as h approaches 0 of 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 6x minus 6h minus 2x cubed minus 6x on h. 2x cubed cancel. Minus 6x plus 6x, they cancel. I can take out a common factor of h on top, limit as h approaches 0. I'm going to have h 6x squared plus 6xh. That's done. Plus 2h squared minus 6 on h. They cancel. When we sub h equals 0 in, so then we get rid of the limit. 6x squared plus 6x times 0 plus 2 times 0 squared minus 6, which is 6x squared minus 6. So that's the long way to differentiate. And it's not too bad with polynomials. It's harder when you get other functions. However, we can also do it by the rule, which you should have learned as well. So what it is, if I've got ax to the n, so I've got some value constant out the front, x to the power of n, the derivative of that, when I derive it, I bring my n down to the front and multiply it by a, and then I get x to the n minus 1. So here, f dash of x, bring your 5 down to the front and multiply it by the 3, and then take 1 away from the power, so to the 4. Bring your 2 down to the front, so 3, 5, 2, negative 2, 2, x to the 1, which is 15, x to the 4, minus 4x. So here, g dash of x, bring your 3 down to the front and multiply it by 6, you get 18x, and then take 1 away from the power, squared. Bring your 1 down to the front, you get minus 4, and then you would get x to the 0, but we know x to the 0 is just 1. If we go back up here, we can go, okay, that function there, f dash of x, is take your 2 down, so you get 8x, take your 1 down, plus 3, that's x to the 0. If you take your 0 down, it's just 0. And have a look, they're both the same. This one here, f dash x, 6x, bring your 3 down, to the power of 2, minus 6, that, and that are the same. So this is derivative by the rule. Okay, so find the derivative, 4x cubed minus 7x plus 4. So first find the derivative, f dash of x, 12x squared minus 7. And find the value of f dash of 1, so that means find the gradient when x equals 1. So we just sub 1 in, 12 minus 7 is 5. Find the gradient of that at the point 1, negative 2. This is the thing that confuses people because they go, oh, hang on, how come I've got 2 values? Well, in actual fact, we just want to find the gradient, so f dash of x, which is 12x squared minus 7, and we want it when x equals 1. We only ever use x in methods, so f dash of 1, so 12 times 1 squared minus 7, which is 5. So that was exactly the same question as the previous one, just worded differently. Here it said find the derivative, and then hence find that. Here it said find the gradient at the point 1, 2. Same question, different wording. Here's instructions on how to do it on the class pad, both ways, and then on the TI Inspire. So you can just pause it if you want and add it in. Okay, so next we're going to have a look at derivatives where it's not y and x. Instead here I've got z as a function of x, so if I find the derivative, dz dx, that's equal to 6x. So when I derive z with respect to x, dz dx, I get the derivative. Here, dx dt is, bring your 2 down to the front, 14t, bring your 1 down to the front, minus 4t to the naught, so it's just minus 4. Here, I want to get dA, whoops, it doesn't look like an A, dA dB, bring your 3 down to the front, 3b squared, minus 10b. So it's just having different variables, which is very common. Okay, with these ones, you've got to expand it first. So y equals, if we expand this, 2x minus 5, 2x minus 5, which of course is 4x squared minus 20x plus 25. And then dy dx, the derivative, 8x, because when we bring the 2 down to the front, minus 20. This one here we need to simplify. So we say y is equal to, we can take out an x on top, x squared minus 4 on x, cancel them. But once we do that, we need to say x can't equal 0. Because we know we've cancelled out a 0 on the, like x can't equal 0 here. Once you cancel that out, it still can't equal 0. And then we say dy dx is therefore 2x. When we derive minus 4, we get nothing. So dy dx, x can't equal 0. This one here, we need to first expand it. So y equals x plus 2 squared is x squared plus 4x plus 4, x minus 4. When I expand this, x cubed minus 4x squared plus 4x squared, they cancel, minus 16x plus 4x minus 16. So x cubed minus 12x minus 16, dy dx, 3x squared minus 12. Okay, these are a bit different. If I said to you y equals x minus 4x squared, and then if I said dy dx, you know that you would just derive that. You would get 1 minus 8x. Basically, that's the same thing here. They've said, find with respect to x the derivative of this. So if I derive that, I get 1 minus 8x. It's the same as saying y equals x minus 4x squared, find dy dx, or d dx of y, and we know that y is that thing there. So dy dx or d dx of that, they're the same thing in this case. So here that means derive that with respect to z. So I'm going to get 20z minus 12z squared. This one here, and you don't write d anything on this side because these two things are actually equal. When I derive this, I get 18z squared minus 8z. Okay. For each of the following curves, find the coordinates and the points on the curve at which the gradient of the tangent at that point has the given value. So we want to know when the gradient's equal to 27. So first thing, find your gradient. Formula. Dy dx is 3x squared. We know that dy dx is equal to 27, so therefore 3x squared is equal to 27. X squared is equal to 9. x is plus or minus 3. But it says find the coordinates. So when x equals 3, y equals 27. When x equals negative 3, y equals negative 27. So we've got 3, 27, negative 3, negative 27. The next one we want to know when the gradient's 0. Remember the gradient when it's 0, that's a turning point or a point of stationary point. So here, dy dx, bring your 2 down to the front, 2x minus 8. We want to know when 2x minus 8 is equal to 0. So 2x equals 8, x equals 4. When x equals 4, y equals 16 minus 8 times 4 plus 1. 16 minus 32 plus 1. That's going to be minus 16 plus 1. It's minus 15. So the point is 4 minus 15. Last one, dy dx is negative 3x squared. So negative 3x squared is equal to negative 12. X squared is equal to 4. X is equal to plus or minus 2. We need the coordinates. So 2, when I put 2 into that, I get 4 minus 8, which is minus 4. Negative 2, when I put 2 into that, I get 4 minus 2 cubed is minus 8, so 4 plus 8, which is 12. So that's how you find x values of a gradient. Now, when a gradient equals a certain value, you can also do it on your CAS. So here, if my gradient is equal to 27, and it's x cubed, so in here we can say d dx of x cubed. When does that equal 27? Interactive advanced solve. So it equals it at those two values. And then if you want to find the y value, you just say given x is negative 3, and then do the same thing with x is plus 3. There's our two values. Okay, this is the last bit. So find the coordinates of the points on the curve with equation that at which the tangent line makes an angle of 45 degrees to the axis. So just say we sketch the graph and it looks like that. We want to know when this angle in here is 45 degrees. So what we're going to do is work out what the gradient of that line is. It makes an angle of 45 degrees with the positive x-axis. If you don't remember, here I can create a triangle. That is my rise. That's my run. So we can say tan of 45 is equal to rise over run, but we know that rise over run is also m. So my gradient is tan of 45. In general, we can say m is equal to tan of theta, where theta is the angle between the line and the axis, or positive x-axis. Okay, so knowing that, we can then say m is equal to tan of 45. If you need to, use your calculator, but that's 1. You can also use special triangles if you remember them. 1, 1, root 2, 45, 45. Tan is opposite over adjacent, so it's 1 over 1, which is 1. I want to know when the gradient is equal to 1, so dy dx of that is 4x minus 7. That equals 1. 4x equals 8. X equals 2. When x equals 2, y equals 2 times 2 squared minus 7 times 2 plus 8. So that's 8 and 8, which is 16, minus 14, which is 2. So I've got the point 2, 2. Then B, it's parallel to that line. So if it's parallel, same gradient. Therefore, m is equal to 3. So now we do the same thing. 4x minus 7 is equal to 3. 4x is equal to 10. X is equal to 5 on 2. Then we sub that back into the equation. So y equals 2 times 5 on 2 squared minus 7 times 5 on 2 plus 8. That's going to be 25 on 2, because 5 squared is 25, 2 squared is 4, but they will cancel. Minus 35 on 2, and then plus 8. 25 minus 35 on 2 is minus 10 on 2, which is minus 5. So then minus 5 plus 8, which is 3. So my coordinate is 5 on 2 and 3. And of course you could do that in your CAS, 2x squared minus 7x plus 8. So here's another way you can do it. 2x squared minus 7x plus 8. Define that. And then you can say d dx of f of x equals 3. Solve. So that equals 3 at 5 on 2. And then if you want to find out what your y value is, f of 5 divided by 2 is 3. Now there's a question there to do, but I'm not going to do it right now because this uses the chain rule. I didn't even look at that, which you haven't learnt yet. So we'll do that one later, but I'll come back to it. If I can get that to rub out. Okay, so that's derivative by first principles and then derivative by the rule.